So hello students, we have already done about image processing, image enhancement, and many types of enhancement we have seen. So one another thing within this there is image restoration. Image restoration means we have to restore the image. Actually we have to degrade it first of all, we know, and we have to reverse and get this image back. So how we can get that one? So let us see. So what are the topics here, what I am going to teach? That one is what is image restoration and what is the difference between image enhancement and image restoration. Then an image degradation we will see, and then we will see our noise models. Afterwards we will see estimation of degradation model and restoration techniques. Other parts are I think do not required for your syllabus. So this is the part. So what is this image restoration? First of all, we are going to image restoration, such as if we have an image, we have degraded the image by applying some type of noise within it. Then what will happen? We are restoring it, we are just reversing the technique, so that what if happens, that the blur it is getting, the actually this noise has been removed. Applying some filters or something like that, we can remove the noise from here. So that one we will see, that how we are just restoring the images. There are some parts of it. So let us see. Another thing is that what is they have said, that image restoration means which that have been degraded. Image restoration attempts to restore the image that has been degraded, already degraded, that has to be, we have to enhance it, such as identify the degradation process and attempt to reverse it. Means what is the degradation, and we are getting back the original restored image. That restored image may not be similar to that of the original image. We have an original image, from that we degraded the image, and then we are getting the restored image. Almost similar to image enhancement, but more almost this one is image enhancement, but not totally, not like that. So next part is what is the differences between image enhancement and image restoration. So the difference between them, we can see that here almost it is written in text. So actually image restoration assumes a degradation model that is known, means actually degradation, this degradation has occurred, we know, and from that we have recovered that image. But actually in image enhancement, that means is whatever we have taken the picture, we have already, not like image in restoration, we have an image, but we are just what we are doing, we are trying to enhance it. Okay, means already we have captured, we do not know that it is degraded one or degraded not. Here what we are doing, we are actually degrading an image, then reversing back from that point. Okay, so that is the difference between them. Such as image enhancement, we have already seen that in some places if there is a noise, that one is occurred due to we have added, we do not have added, we have just taken the picture and some sort of noise has entered by default. But what will happen in image restoration, actually here what happens, here we do degradation first and then we restore it. Okay, so but we will not get image restoration, try to recover the original image from the degraded without prior knowledge of degradation process. But here we know about the degradation process, so we can reverse the thing. Okay, so now let us see what is image degradation model. Some of the models we can see and examples also we can see. So in degradation model, what we are seeing here, we have an image, we are applying a degradation function on it. Okay, H denotes that one. Then we obtain an image after degradation. So here actually how degradation is occurred, here a function is applied and from below a noise is being inserted here. So the noise and this function, both of them combine and they create a image. That image has to be restored. Okay, So that image, on applying the reverse technique, we can restore it. So it may be occurred in spatial domain as well as in frequency domain. So spatial domain is denoted by small gxy. This one actually we are getting gxy by applying a function on it, that is hxy is a function, and hxy is applied on fxy. Fxy means a pixel, and thereafter a noise is being added with it, so it becomes degraded. And then in frequency domain, what happens? Frequency domain, they are denoted with just capital letters, and here also actually the same thing is occurring but in frequency domain it is occurring, and noise has been added here. Both of them, the noise will be added. Actually all these things are important mainly from the point of view of mathematics, as in image, and also in quantum mechanics, and also in machine learning also mathematics is very much needed. So some of the noise models we will see. So noise models such as, here is one of the most important noise model. Noise model means we will apply this model. This is going to apply the noise, such as Gaussian is one type of noise, Rayleigh is one type of noise, Erlang or Gamma is one type of noise, exponential. So all this we will going to explain later on in a more explanatory manner. So but at least you know that these are the noise models. So impulse is there, one is salt and pepper noise. Salt and pepper noise, we can see just the idea of those things, such as noise models. Here is the original image, but noise models effect they have shown. This is the original image, and histogram of the original image is given on the right hand side. So what will happen? So if we are applying the Gaussian noise, at that time this histogram is changed, and we can see that some noise has been applied to it. Rayleigh ones, so actually it is changing some functions are there. Actually we can see it by the side of this one. There is a value, it is given 1 by square root, like this something they are changing the what we can, this is the PDF means probability density function. So that has been changed, and due to that, not going to the just in details, just these are the things, such as Erlang, they have an equation like that. In MCQ they may ask this one, that which one is which type of things. Just let me, okay. So these are the things. Uniform, in uniform it is occurring in a uniform manner, and impulse manner is given, and exponential is also given, and Rayleigh one is also like almost similar to the Gaussian. So these are the things. So when applying, after applying, we have seen that histogram equalization, actually histogram are being changed, and the effect upon it we are able to see that it is occurring like this. So and also here another, that one is continue, last 4 parts are left. Exponential is this one, and uniform is this one, and salt and pepper. Salt and pepper is a common one. So actually such as salt and pepper, if we mix and spread on it, so like that some image degradation will occur. So we know that this one is applied salt and pepper, so we have to come back from this degradation. Okay, so this is up to